Okay, so this was actually the bell work from yesterday, and because I'm combining two lessons today, this is something you can try at home. But if you just write a positive number, any positive number on a piece of paper, and then you start keying in all of these operations on the calculator, at the very end, what answer do you end up with, and does it make sense, and why? And then you study what you did and try to figure out why you got the answer you got. Okay, and so I'd like for you to try that over the weekend instead of doing it in class, because I need all the time today for our catch-up time. And let's move on. Okay, so yesterday we learned about these three properties of logarithms. We had the product property, quotient property, and power property, and we learned how to finagle them and work with them and solve some problems. And we worked on 7-4, the first few problems, and then we moved on to the next problem. These are things we did yesterday. We learned problem 1, then we worked problems 1 through 6, and then we did problem 2, and then we worked problems 7 through 12 with problem 2. And then at 13, you just do, after you do those two, it's basically create 3 of your own problems that you can use these properties on. Okay, so you should have had this first side completed today when you come in. Now turn it over on the back. This is where we're going to begin today. So basically, we're going to work with something called the change of base formula, which says for any positive numbers m, b, and c, b and c cannot equal 1, either one cannot equal 1. So if we have log b of m, that's the same as going to a different base of log c, but it's log c of m over log c of b. Okay, so they just switch to a different base. And basically, the bigger the m, the one that's higher up in the line, he's on the numerator, and the one that's lower in the line is on the denominator. And that's how I remember. This one's the one on top, that one's the one on bottom. Now, let's look at some problems with these. Okay, so first it says, what is the value of each expression? And they give us log base 81 of 27. So you have to think about, how can I simplify this? What common base has powers that equal 27 and 81? Well, that would be 3, because 3 to the third power is 27, and 3 to the fourth power is 81. So they both share that common base. So we're going to simplify rewriting 81 and 27 as powers of 3. Okay, we're going to use our formula first. So we just learned, if we had log b of m, that's the same thing as log c of m over log c of b. Well, what we're going to do here is change it to the third base, right? Because that's our common base, 3. So we're going to write log 81 of 27 is log 3 of 27 over log 3 of 81. Remember, the higher number goes on the top, the base goes on the denominator. And we're switching to log base 3 because of the common base between those two numbers. Now we're going to rewrite 27 and 81 as factors of 3 and simplify. And they didn't show that part. Right? So they just assume that you're good with this by now, and they don't have to show it again. So I will show you that step. So we're going to take log 3 of 27, and 27 is what? 3 to the third power over log 3 of 81. And 81 is just 27 times 3, so it's 3 to the fourth power. Right? So now these cancel, right? And we're left with 3 over 4. Okay, so that's how you get this answer. Now, that's method 1. let's look at method 2. Turn on your calculators and clear them. Now what if I don't want to deal with finding a common base? What if I just want to use our common logarithmic base of 10? Okay, so if I do that, I can just rewrite this log 81 of 27 over log 27 equal to log 27 over log 81. Let me write that again. So log 81, for those of you who can't see the teeny numbers, of 27 is equal to, and I'm going to write it down here, log 27 over log 81. So again, the 27, that's on the numerator, and 81's on the denominator. All right, so when I have these, now I can just plug it into a calculator. So let me show you how to do that. All right, so turn it on and clear whatever is there. And I want you to find your log key. And we're using the TI-30XS calculators. So you want to look for that second function, the green button, and it's up on the very left-hand corner. Go down 1, and you see a key that says log. This is the one we're going to use. Okay. Now we're going to do the log 27 divided by log 81, and we're going to see how we do that. Now ignore that because that's a graphing calculator, and we're going to do ours a little differently. So press your log button and type in 27 and close your parenthesis. Now press enter, and you should get something like 1.431363764. Now we want to take that and we want to divide it by log 81. So just hit divide and it'll show answer divided by. And now type in log 81. So hit your log 81, close parenthesis, and press enter. Now you should get that 0.75. Okay, if you did not, I need you to raise your hand so we can do it again. Everybody get that? All right, so not bad, huh? Pretty easy. So we're going to skip method 1 and we're going to use the calculator method 2. And you'll be able to do that on your test as well. Okay? So let's look at 14 together. Oh, actually, before I do that, let's do one more. So let's just do this with the calculator, okay? So they give us log 536. Log 5 of 36. So we know we're going to turn that into log 36 over log 5. So I want everybody to type that in now. So hit clear and now solve this one. Did you get 2.226 blah 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 blah? And we're going to round that up to 2 decimal places. So look at your third. It's a 6, so that means we're going to round this guy up to 3. So it's going to become equivalent to 2.23. Is there anybody who needs help? Is there anybody who didn't get this answer? I didn't do the workbook. I was doing an example.
Oh.
Okay, so if there's no other questions, I would like for you to work 14, 15, and 16 in your workbook. And I'm going to give you about a minute. What you don't finish, well, no, you need to finish. So, do that one. And actually, that's everything. So I'm going to give you 2 minutes to do 14, 15, 16, and 17. 17 is just read it and tell us what the error is. So you're going to have 2 minutes. If I can find my timer. And then we're going to move on to the next assignment. All right. 2 minutes. One minute. Thirty seconds remaining. Five seconds. Okay, so wrap up your last page there and pass them forward, and I'll come pick them up, and we're going to move on to the next lesson. The next lesson is 7.5, Exponential and Logarithmic Equations. Our objective is to solve exponential and logarithmic equations. So now we're going to get it down to x equal an answer. Right, and we're not going to do bell work because I'm combining 2 days into one. I want to talk about exponential equation. So if you'll read this while I pick up your papers. The basic meaning here is what's highlighted, the exponential equation. An exponential equation is an equation that has a variable in your exponent. So 5 to the 6y. Right, so I've got a variable in my exponent. So these are exponential equations that we've got to solve for that equation, but it's up in an exponent. So we're going to learn how do we solve those. And what we've been doing, logarithms. Remember, logarithms undo powers. Inverse of a power is logarithm. So we can use logarithms to solve exponential equations. So this is where we've been leading up to and why you've been learning what you've been learning. This is going to be our test and what's on the test, but it's on your sheet as well when I printed out your study guide sheet. I am, though, and I hope the morning classes are watching this, I'm knocking out the word problem from today because there was a lot of confusion about it, and it showed a couple of things that could be a little ambiguous. So I knocked it out, and I'm going to knock it out of the test as well. So now we're down to 16 questions on the test. Something I want to also let you know is the quiz that you took the other day was exactly the first half of your test, right? Just different values. So on that quiz, those first 9 questions on the quiz, the 9 questions were the first 9 of your test with different values. Okay, so it was from these. From lesson 7.1, 7.2, 7.3, it was these problems. And like I said, you're going to get this when you get your study guide. But when I talk about problems, I'm going to try to be a little more specific about equations and problems. I should say exercise and problems. Problems will be what I'm teaching with, the problems from the textbook that are the teaching tools. Now, when I say problem 1 and 3, I'm talking about these. I'm showing problem 1 today, and let's clear that out. Problem 2. Those are the problems I'm talking about. I'm not talking about number 1 and number 2 on your exercise, on your practice K. All right? So I'll teach a problem and then have you do a problem set. The problems that I'm teaching, those are the topics that's on the test. Okay. So when I talk about this, 7-1, problem 1 and 3, we'll go back and hopefully in your notes you are writing these problems right here that I put up every time I teach a problem. Right? So this problem's on the test. Okay. But you'll have this on your study guide. I've got to move on. Problem 1 here says solving an exponential equation with a common base. It's a multiple choice. What is the solution of 16 to the 3x power equal 8? Well, there's that exponential equation, right? Because our variable is in the power. So what we want to do is we want to write these in a common base. Okay, so start off by writing your equation, 16 to the 3x power equal 8. Now we want to try to find a common base between 16 and 8. And we know, because we've worked with it so much, it's going to be 2, right? Because 2 to the 4th power is 16, and 2 to the 3rd power is 8. So replace 16 with 2 to the 4th, and replace 8 with 2 to the 3rd, keeping your power, right? Because 16 is 2 to the 4th. Well, it was 16 to the 3x power, so we have 2 to the 4th to the 3x power, equal 2 cubed. Now we've got a power of a power, and what do we do with power of a power? You multiply. So multiply 4 times 3x, and we get 2 to the 12x power. And just drop down 2 to the 3rd. So now we have 2 to the 12x equal 2 cubed. Well, now we're back to that problem that we've been working for a few days. Well, if I have 2 to the 12x equal 2 to the 3rd power, well, we know 2 is equal to 2, so let's just work. That means that these must be equal. So let's just work with our exponents. 12x equal 3 and solve for x. And you get x equal 3/12 or 1/4. Right? Everybody with me? Right. So now we have x equal 1/4. And that's our answer. Now, I love it when we get it down to a specific number, x equals this or y equals that. We can plug it back in and check to see if we got the right answer, right? Because if we plug in 1/4 into our original equation up here in this power, 3 times 1/4 is 3/4. So if you go 16 to the 3/4 power, or 3/4 is just 0.75. So try 16 to the 0.75 power right now and see what you get. Do you get 8? So 16, and to do a power, you do the symbol that looks like that. So type 16, it's a caret. It looks like a rooftop. So 16, rooftop, 0.75, and press enter. What do you get? 8. Okay? So it checks out, so our answer is correct. All right. That and the book said it was right too. So any questions on that? Right, so our answer would have been A, 1/4. Let's look at your assignment on 7-5. Let's work some together. Look at number 1. They have 125 to the 2x power equal 25. What's our common base between 125 and 25? They're both powers of 5. So 125 we can rewrite as 5 cubed. 5 times 5 times 5 is 125. But don't forget, it's still to the 2x. So we got 5 cubed to the 2x equal, and 25 can be written as what? 5 to what power? Five to what power equals 25? 2. But guys, that worries me that there just wasn't a shout out from everybody. 5 squared is just 5 times 5, 25. Okay, so we've rewritten 125 as 5 cubed and 25 as 5 squared. Remember, 5 times 5 times 5 is 5 cubed. So look, 5 times 5 is 25. And then 25 times 5, think of 5 quarters. If you have 5 quarters, you've got what? $1.25, 125. So that's 5 cubed, and then 5 squared is just 5 times 5, which is 25. So we rewrote both 125 as 5 cubed and 25 as 5 squared. Thumbs up if you're with me to this point, thumbs down if you're not. I need to see everybody's thumbs. Thumbs, okay. Thumbs, okay. Looks good. All right, so now let's continue. What happens now that we've got the same base? Oh wait, we can't do that yet, right? We have to pay attention to our power of a power. We have to multiply that. Right? Power of a power, multiply. So we're going to have to multiply 2x times 3, which is 6x. So we get 5 to the 6x power equal 5 squared. We're just going to drop that guy straight down. Now that we have the bases equal, we can just deal with the exponents. 6x equal 2. I'll start it over here. 6x equal 2. Divide each side by 6. We're solving for x, right? So x equals 2/6, or simplify it to 1/3. Okay, is everybody with me? So you've got number 1 done. Now I'm going to give you 1 minute to work 2 and 3. So work those now. Two has already started for you. So when you get just the base equal a base, and you just get rid of that base and deal with the exponents. Solve for x. Ooh, it's loud. Okay, someone want to tell me what they got for number 2?
I got x equals 3.
That's correct. X equals 3. So if you didn't get that, you need to rework it at home and figure it out. Did anybody get through number 3?
I also got the number 3.
Yeah, that's not correct. So, what?
I know, I said I also got through number 3.
Oh, okay. Wait, somebody else said it. What? 1/4? That's correct. So, sorry, I misunderstood, James. So, yes, 1/4 is the answer for number 3. So now you know your answers. So at home tonight, if you didn't get these or you didn't finish it, now you know what you've got to work to and make sure you got it right. Okay? Any questions? Let's move on to the next problem. Now they're telling us another little rule here. They're saying when bases are not the same, like when you can't solve a base, there's a way to handle that. If we can't get equal bases, then we can't get rid of those bases and just solve with the exponents. So there's got to be another way to deal with them. What they're saying, if we have one thing equal to another, then the log of each one of those should be equal to each other. So if I have m equals to n, oh, I've got it written up there. Okay, if m equals n, then the log of m must be equal to the log of n. So if x equals y, then log x equals log y. Right? Okay. So let's apply this to solve things that when we can't get the same base. So let's take a look at problem 2. This is also on your test. What is the solution of 15 to the 3x power equal to 85? Well, I just can't even think or quickly see that I can get a common base there. And I don't want to spend a long time guessing and checking. So I'm just going to apply my new rule. See where that's going? So what do? Take the log of each side. So the log of 15 to the 3x power is equal to the log of 285. Now we have that rule from yesterday that says if I have a power, that 3x power, we just move that over in front of the log, right? We simplify with our power property of logarithms. So this becomes 3x log 15. And then carry down the log 285. So now let's just solve for x. That means we're going to leave x and get rid of everything else. Well, all three of these things, 3 times x times log 15. Well, to get rid of the 3 and the log 15, we've got to divide by that. So divide each side by 3 log 15. And it doesn't show that. But when you do, 3 log 15 on each side, 3 log 15. The 3 cancels out, log 15 cancels out, and it leaves us with x. So x is equal to log 285 divided by 3 log 15. Okay, everybody with me? Now get your yellow calculators and I'll show you how to do this one. Everything in blue is what the calculator did when I pressed a button. Everything in red is what I had to type in. So here's what we're going to do. Turn it on, hit clear. Now press your log button. We're going to divide these two logs. We're going to divide log 285 by 3 log 15, and here's how we do it. So press your log and then type 285 and close parenthesis. Now hit your divide. Now open parenthesis, because we've got to put all that denominator, 3 log 15, that's all got to be in a parenthesis. So open paren. Now type 3 times. Now hit your log. And now 15, close parenthesis, close parenthesis. So 2 close parentheses and press enter. And if you did everything right, it should come out to 0.69576, blah, 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 blah. Is there anybody who didn't get that? All right, that's all there is to this guy. All right, let's do one more. Oh, and to check it, plug this, what you got for x, plug it back into the original equation. So 15 to the 3 times this power. And note that if you use the rounded version for x, that it's going to be slightly different, just slightly. Right? But if you use the whole number that you just calculated, like times 3, store that and put it to the 15 to that power memory. But just know if you use the rounded x value up here, it's going to be slightly off because of rounding errors. Okay? So it'll be close, but not exact. Any questions? All right. Let's look at your first problem, number 4. So you will work 4, 5, and 6, and then I want you to scribble out 7, 8, 9, and put an x through 10. We're not doing 10. Okay, and that won't be on the test either. It's on the test, but we're just going to put an x through it. All right. So let's look at number 4. We have 6 to the 4x equal to 34. Okay, so what's our first step? If we can't get those to the same base, what do we need to do? It's just like the one we did before. So what do we need to do when you can't get your bases? You can't get a common base. What do we do? Take the what of each side? Log. Thank you. So log of 6 to the 4x equal 230, whoops, each side, right? Log of 234. Just take the log of each side. See, you learned the hard way. Now here's the easy way. Now we've got to get rid of this guy, right? With our power property that we learned yesterday, that power property can go in front of log. So it becomes 4x log 6 equal log 234. Now we have to solve for x. All of these are multiplied together. That's like saying 4 times x times log 6, right? So if I want to get rid of everything but x, because they're multiplied together, I have to divide to get rid of them. So divide by 4 log 6. And if I divide that side by 4 log 6, I have to divide this side by 4 log 6. Now, my 4's cancel out, and my log 6 cancels out, and I'm left with my x. So now I have x equal, what was that one? Log 234 divided by 4 log 6. Now, type this into your calculator and tell me what you get. Remember to use parentheses to group all that stuff on the denominator. And close your parentheses. Did I get it right? I did. I'm getting better. I'm not the best on calculators, but I'm someone who chooses to do it by hand. but these are easier to do, believe me, on a calculator. So you should get something close to 0.76. It's 761168171. Right, and I'm going to truncate all that. There's no rounding because that third space or third place is a 1. So our answer is 0.76. Is everybody good with that? You're so quiet. I know it's Friday. I hope you're lively before the pep assembly. So now do 5 and 6. Okay, and then we're done for today. All right, thank you. This will conclude our video.